Hi, I'm Athman. I did this presentation with Yasin Hazim and Saif Haytham about types of bridges according to their fabrication. First thing I will talk about is what's the bridge? A bridge is a structure built to span a physical obstacle, such as a body of water, valley, or road, without closing the way underneath. It is constructed for the purpose of providing passage over the obstacle, usually something that is otherwise difficult or impossible to cross. What are the components of bridges? There are superstructure and substructure components. Superstructure components are deck, girder, and bearing. Substructure components are piers, wing walls and the returns, abutments, and foundation. There are many types of bridges according to their fabrication. First one is cast-in-place bridges. Second one is the precast bridges. Third one is the pretension bridges. And last one is post-tension bridges. Cast-in-place bridges. Cast-in-situ method of construction of bridges is a flexible method in which the demands of more unusual geometrical shapes can be easily coped with. Cast-in-situ methods are adopted when it is hard to transport the fabricated parts due to size or unreachability. Now, what's the advantages of this method? This method doesn't require any heavy lifting equipment or transporting equipment, since the casting of superstructure is done in the required position. The superstructure is safe from transportation and lifting dummies. It is the best method to construct a bridge in inaccessible areas. This method is used for cost-effective construction of solid, voided, or ribbed reinforced concrete slab bridges. Now, what's the disadvantages of this method? It is time consuming as compared to precast construction methods. If the bridge is constructing over water bodies, severe damage may occur to the unset concrete during flood conditions. This method requires large number of workers and requires skilled supervision. There are many different cast-in-situ methods. First one is incremental launching method. It is highly mechanized method which saves time and budget. It is generally preferred for the construction of multi-span post-tension bridges. Second one is balance cantilever method. It is the advanced method of all construction techniques since it doesn't require any temporary structures for support. The bridges of greater heights can also be built using balanced cantilever method without false work. Cast-in-place technique for balanced cantilever method of bridge construction is preferred when the bridge is long and contains irregular span lengths. And last one is cast-in-situ post-tension method. It is more demanding method because of its durability and applicability to complex bridge curves. Precast bridges. In these bridges, various concrete geometric shapes are casted in the factory and then transported to the construction site. They have several properties. First one is low initial cost because costs are lower for formwork and scaffolding. This method has the minimum maintenance of all methods. They are constructed by using high quality materials to exacting manufacturing tolerance. The precast components are easy to erect in any weather. Fast construction, reduced traffic handling cost and accident risk. More work can be accomplished in less time with less delays and disruption. Pretension bridges. In these bridges, pretension concrete is used where the tendons are tensioned before the concrete being cast. The concrete bonds to the tendons as it cures, following which the end anchoring of the tendons is released. The tendon tension forces are transferred to the concrete as compression by static friction. Pretensioning is a common prefabrication technique where the resulting concrete element is manufactured remotely from the final structure location and transported to site once secured. It requires strong, stable, and end anchorage points between which the tendons are stretched. These anchorages form the end of a casting bed, which may be many times the length of the concrete element being fabricated. This allows multiple elements to be constructed end to end in the one pretensioning operation, allowing significant productivity benefits and economies of scale to be realized. Post-tensioned bridges. In these bridges, post-tensioned concrete is used where the tendons are tensioned after the surrounding concrete structure has been cast. The tendons are not placed in direct contact with the concrete, but are encapsulated within a protective sleeve or deck which is either cast into the concrete structure or placed adjacent to it. At each end of a tendon is an anchorage assembly firmly fixed to the surrounding concrete. Once the concrete has been cast and set, the tendons are tensioned by pulling the tendon ends through the anchorage while pressing against the concrete. The large forces required to tension the tendons result in a significant permanent compression being applied to the concrete once the tendon is locked off at the anchorage. Thank you for listening. If you have any question, you can find me at my email.